Um, so Suitability Modeller. It's a tool within Arc Pro. I'm not sure how many of you have had a look at it before, but it requires the Spatial Analyst extension, and that should already be included in your license from Esri, so you shouldn't have to add anything to your current license. And I think it's really useful because it allows you to combine a number of data sets together to provide an indication of the best location for your work. It gives you a lot of control over the weighting and criteria of your input data sets. So it's really quick and easy to play around with the inputs and then see how that changes the suitability map. And I really wish that I'd had this when I'd done the ecosystem services assessment for the Eden, because it would have been perfect. But I'm sure a lot of you do similar work in terms of prioritizing where you want to deliver. And so I think it could be a really useful tool for you if you haven't already used it. So you can find it on the Analysis tab in Arc Pro, and the workflow has 4 key steps. So the first is you determine and prepare your criteria data. You then have to transform the values of each of those to a common suitability scale so you can compare them. You then weight each criteria relative to one another and combine them into a suitability map. And then finally, there's an optional step at the end that you can use something called the locate tool, and that will identify specific areas for the work that you'd like to deliver. And we'll go through each of these steps in the webinar today. So to demonstrate the workflow, we're going to go through a really simplified example to find optimal locations for tree planting. In reality, you'd need a lot more data sets than I've included in this example. And you'd obviously be including your experience of working in your catchment and additional considerations based on your local knowledge of the area. But to keep it simple, we're just going to have about 4 input data sets for this webinar. Excuse me. So the first step is to determine and prepare our criteria data. So we need to have a think about which information would be useful for assessing the suitability of land for new woodland planting. So as I said before, it's a simplified example. So we're just going to look at these 4 things. So existing woodland, PT soils, agricultural land quality, and whether it's common land. So then we need to identify what data sets we're going to use to represent that information. So for this example, I'm going to include the National Forest Inventory from the Forestry Commission, and that represents existing woodland. We've then got the PT soils location map from Natural England, so we can avoid planting on peatland. The Provisional Agricultural Land Classification, or ALC data from Natural England, so we can avoid high-grade agricultural land. And then finally, Registered Common Land from Natural England. The choice of input data is obviously completely up to you and will depend on the specific project that you're working on. So for example, another option for the woodland input would be to use the individual habitat network maps from Natural England. So those have expansion zone areas mapped, so you could include those in your analysis if you wanted to. All the examples that I've chosen for this workshop, they're all on the ArcGIS online portal, so you can bring these in and follow through the example if that's useful. So the next thing that you have to do is to clip your input data to your area of interest. And then if your input isn't already in raster format, you'll also have to convert it to raster. So you can do this using the feature to raster tool. You can see in the video. Put that going. So when you specify a field to use when you're running the feature to raster tool, just make sure that you choose the field that you'll be using for your suitability characterization. So for example, if you're converting the ALC grade data to a raster, then you select the field named ALC grade, just so you can identify it at the future, for the next step. If there's no identifying field, for example, if you have a data set where there is only one type of feature, such as if the area is classified as common land, then you can use any category field stage. But you'll need to do a bit of fiddling around with it later on. You also need to open up the environments pane and specify the processing extent. So that will ensure that when you run the feature to raster tool, the resulting raster will be limited in its extent to the area that you're interested in. So here I've used the Emont catchment. One thing to watch out for is that the input that you use for that extent, make sure that it's not in a group in the contents pane, because for some reason, I don't know if it's just my machine, but the geoprocessing tool doesn't seem to honor that processing extent if the feature is inside a group. So it's just something to watch out for. You also need to decide on a raster cell size for each raster. So in this example, I'm using quite large scale data. So I've chosen the 50-meter resolution. But again, that will depend on your project and the granularity of your input data. You'll need to run through this feature to raster process for each of your input data sets. And one thing to do is once your first raster has been created, then if you create subsequent rasters, if you snap them to the same grid as your first one, then they'll all end up in the same raster grid, which is what you want for the next step. Okay, so once you run through that first step, you should then have 4 new raster datasets. So there should be 1 for each of your input datasets. They should all be the same extent, which is the extent of your area of interest. In this case, it's the Emont catchment in Eden. They should all have the same cell size, and they should all be snapped to the same grid. Now, the next thing that you have to do is to reclassify the rasters to convert any no data values in that information to 0 or for a suitable descriptive value. So you can use the reclassify geoprocessing tool. And the video is just going to go through that. So for example, some of your rasters will have areas in them that have no data values. And we need to change this because we need every pixel in the input raster to have a value, so it will work in Suitability Modeller. Again, you just need to set the extent to the same as your catchment boundary and snap the raster to the first raster that you created. And it will take a little while to run, but when it completes, you'll see that you've got values for all of the cells in the raster. So any cells that were previously classified as having no data will be classified as 0, which means that we can then input it into the tool. I'll just skip forward on here so you can see the output. So you can see here we either have it's non-woodland or woodland as our output. We don't have any part of the tool that, any part of the data that doesn't have any value. The next step is to transform your data to a common suitability scale. So this is necessary so that you can combine the data sets in a meaningful way. You need them all to be on a common scale. We're going to use a 1 to 5 scale in this example, but you can use anything that you like. There's quite a few options in the tool itself. We can classify the data according to how suitable they are for tree planting purposes. In this example, the higher the suitability score, the more suitable it is for tree planting. So for existing woodland, we'll say that the suitability for new planting is 1, so low in areas of existing woodland, and 5 in areas of non-existing woodland. In reality, you're likely to have additional categories here, such as areas of your catchment which have been highlighted as a particular interest for tree planting. Next, for peaty soils, we can assume that deep and shallow peat are highly unsuitable. Soil with peaty pockets is unsuitable, and non-peaty soils could be suitable. Likewise, for agricultural land, we can assume high-grade land is likely to be less suitable and poor grades more so. Finally, you might want to highlight common land as being trickier for tree planting and therefore less suitable. It will depend on your knowledge of the catchment. The next step is to actually open up the tool itself finally and create your model. So you first choose a name and select your model input type, which is criteria in this case. We decided to go for a 1 to 5 scale, and you can also change the way in which the inputs are weighted. We'll leave this as the default as multiplier for this. And finally, you specify a name for your output raster. The next step is to add all your input rasters on the suitability tab. So here's where you can select all your reclassified rasters that you've already prepared in the previous steps. And if you click on them one by one, you can actually update the suitability values for each by selecting the correct field and overwriting current values. So the values that we had in the previous slide. And the nice thing about this is that the preview of your suitability map will automatically update to show you where the most suitable areas are in your catchment according to the current suitability values. So you can play around with it and it gives you a lot of control. You also have the option to change the weighting of each input raster. So if you prefer to give more weight to the avoidance of peaty soils, then you could increase that. And then when you're happy with the preview, you can run the model to create the final suitability map. And the final optional step in the process that I mentioned earlier is to use the locate tab to select the optimal locations for your purposes. So you can specify the total area of tree planting that you'd like to create. And then you can also specify the area units you'd like to use. So in this example, we'd like to create 200 hectares of new tree planting. You can then specify a name for your output raster and the number of tree planting areas you'd like to create. So we'll say 5, and you can add as many as you like. Next, you choose the region shape, for example, a square, triangular, circle, which seems, it'd be nice to just have it as a polygon. No, no features in nature are going to be nice handy shapes, such as circles, but we'll leave it for the default, which is a circle at the moment. And the next option is to alter the shape utility trade-off. Now, this is just how much weight is given to maintaining the region shape versus the values in the suitability map. For example, in our case, the values are more important than maintaining the circle shape, so we can reduce that to 20%. And finally, you can choose the evaluation method. So there are lots of options here, but we can leave it as the default. And that's it. So the output raster will rank the most suitable regions from 0 to 5, with the region allocated 5 being the most suitable areas for tree planting. And as I said right at the beginning, it's obviously a highly simplified example. And in reality, there'll be lots of local considerations to take into account of where to carry out tree planting. But hopefully it'll give you a good idea of how the modeler can be used and applied to some of your projects. Esri produced some really useful resources to support the use of Suitability Modeller. I'd recommend having a look at this video and the workflow description if you're planning to use the tool.